In this question, we are being asked to calculate the axial stress in the cables of this system. So we see that there's a sheet of material that's being suspended in the air by two cables. We're going to assume that these cables have the same length, they have the same cross-sectional area, the same elastic modulus, and we're given a density for this acrylic sheet along with some dimensions, height, width, and thickness. So what we see here is there is a force on these cables which are really acting as uniaxial bars due to gravity. And we have two cables, which means that the force is being divided evenly between them. At least if we assume they're the same length, and things are balanced appropriately. So stress can be given as the force in a cable divided by the cross-sectional area of a cable. And generally speaking, a force is mass times gravity. In this case, to figure out what the mass is, we have to know or use the density, which is 1,000 kilograms per meter cubed, and a calculated volume, okay, for this object. So it's going to be the height times the width times the thickness, like we see here. Now, notice I said this was a general force is equal to mass times gravity. The force in a cable in this problem is going to be half of this force. It's going to be because the force is being distributed evenly between these two cables. Now, we can rewrite this expression for the stress in a cable. A stress in a cable is going to be 1/2 times the total weight divided by the cross-sectional area of the cable, and we can write that out as we see here with all the values of the variables substituted. So once again, we can use Google to attempt to make this problem solving a little bit simpler. And we'll go ahead and say we have 0.5, we have 1,000 kilograms per meter cubed, we have 1.4 meters, we have 0.7, I guess I'll put you may be smart enough, but I'm not sure actually if it is. We have 1 centimeter, and we have 9.8 meters per second squared, and then divided by 0.1 centimeter squared. And what are we hoping? We're hoping that the units that this spits out will be those of stress, so pascals. All right, we hit enter, and wow, there we go. We have a lot of pascals, 4,800,000 pascals. Well, what are the units that we want? We want it in megapascals. So we can say in megapascals, and that comes out to be 4.8 megapascals. If we want to do the problem in Python, we can go ahead and create a new Google Colab file, and we'll import NumPy. Oh, too many active sessions. Okay, well, that's too bad. Let's go ahead and delete some of these. Yeah, we'll terminate the other sessions. That's fine. Okay, great. And then we'll continue with our code. We have a density, so we'll call that rho of 1,000. And then we have kilograms per meter cubed. We have a height or of the object in question, so that would be 1.4 meters, like that. We have a width, we'll call that W, and that's 0.7 meters. We have a thickness of the object, so T, yeah, it should be okay. We'll say that's going to be 1 centimeter, but it's not supposed to be in centimeters. We want it to be in meters, so we'll multiply by 1/100th. And we have G, and we're going to use 9.8. It's thinking for me. okay, like that. So we're using all base units. The cross-sectional area of the cable is given as 0.1 centimeters squared, but we need it in meters squared. So that could be a little bit tricky. So, 1 meter is 1/100th. We're going to have 1/100th times 1/100th. That'll give us 1/10,000th, which is 1 even minus 4. Okay, so now we can write out that sigma is equal to 0.5 times rho times height times W times T times G divided by A. And we can write that the sigma is going to be equal to MP dot round, and we'll plug in sigma. The answer they want is in terms of megapascals. This would have given us the answer in pascals, so megapascals will be 10 to the minus 6. We'll go to 1 decimal place, and then we'll write out that it's in megapascals, like we see there. And hold on, we're missing a little bit. Yep, just like that. Okay, and we can hit Control Enter. Oh, but it's going to spit out an error because it didn't run this first. So first we got to run this. Okay, and then did it run? Okay, yeah, it ran. Then we can run this one. Okay. Well, it's still saying it's not defined. Interesting. Hold on. I think something weird just happened here. Oh, yeah, I don't know what happened. Okay, it ran it then. So I didn't do anything, but I made sure that I guess I had time to run that library or load that library first. So sigma is equal to 4.8 megapascals, which is what we calculated previously. Okay, thank you for watching the video. I hope you found it useful.